In this lesson, we're going to play with our three derivative rules and just work with them a little bit in terms of how we can simplify these expressions. Because where we want to go next is we want to deal with applications, word problems. And often if we have a simple derivative, it's easier to work with than a more complicated derivative that has lots of parts and pieces. So a quick review. I want to find a derivative and simplify it. So I want to apply our rules. Okay, my derivative here, I'm going to use the power rule because I have an exponent. 5 times negative 2 is negative 10. Our base stays the same. Subtract 1 from our exponent. And don't forget the derivative of the base. So the derivative of the base would be 8x plus 2. And we could simplify this a little bit by multiplying the 10 by this stuff. If we did that, negative 10 times 8x would be negative 80x, and negative 10 times 2 is negative 20. I can multiply all of that by our repeated bracket. When we have repeated brackets, we don't simplify them. There's no point writing it out 4 times and doing FOIL, so we just leave it like that. That's as simple as it gets. Okay, but 2 parts is better than 3 parts. If we look at the next one, letter B, okay, this is a function with a rational in it. Well, before we start, it might be easier to think of this as a base with an exponent on it. So it turns it into a power rule again. I want to take my derivative. I could do it the same way to the previous one. So 1/2. My base stays the same. My exponent, I subtract 1, and 1/2 minus 1 gives us a negative half times the derivative of the base. 3x squared minus, oops, not to be an 8 there. 8x plus 6. Okay. If I want to simplify this one, I need to think of fractions. On the bottom of the fraction, well, there's definitely the 2. Okay, so put that on the bottom. I can keep the 1 on the top if I want to. Also on the bottom, anything to a negative exponent puts it on the bottom, right? So I can think of this as x cubed minus 4x squared plus 6x with a half on the bottom. And for the last piece, the exponent here, we don't see one, but we know it's a 1. So it's a positive exponent, so all of that stuff goes on the top. And there's my simplified form. Now, obviously, you don't have to put the 1 in if you don't want to. You could just write this as 3x squared minus 8x plus 6 over, and you don't have to write it with an exponent on the bottom. You could put the root back in. So these two answers are interchangeable answers. I don't really care which one you use. They're the same thing. Power of a half, an exponent, the one out front or not. Okay, so some examples of our power rule. All of the rules, power rule, quotient rule, product rule, can be used in combination with one another. And when you use them, they often make really complicated looking derivatives. So we want to simplify them. When we do this, the biggest idea that we're going to use is the idea that there's probably going to be some sort of common factoring going to go on. In particular, if you're using the product rule or the quotient rule, because you're going to have 2 halves to your derivative, and they should have something in common, in most cases, between those 2 halves. So we'll take a look at some examples here and show you how this is going to work. Okay, so differentiate, so take the derivative, and simplify fully. If I look at this question, I say to myself, there's 2 parts. This is a product rule question because I'm multiplying. So the product rule states that if I do the derivative of the first half, so 3 times x squared plus 5 squared, subtract 1 from your exponent, times the derivative of just the base, which is just 2x, times the second piece, 4x minus cubed squared. I then can add that to the derivative of the second piece, so 2 times 4x minus 3 to the 1, times the derivative of its base, times the whole first piece, x squared plus 5 to the 3. Well, if you look at this, you may notice that there are 2 halves, and the plus sign separates our question into the 2 halves. There's things that are in common in both halves. Okay, I see that shows up over here. I see the number 2 shows up over here. And I show that this stuff shows up over here. So we have a bunch of common factors. What I prefer to do if I simplify things is take those common factors out. So I'm going to take out the number first, the factor is a 2. I'm going to take out an x squared plus 5, and I'm going to think to myself, well, this one has 2 of them, and this one has 3 of them. How many can I take out? What do they have in common? They both have at least 2. Our rule has always been to take out the smallest exponent, right? They both have a 4x minus 3 in them. Again, let's look at our exponents. A 2 compared to a 1. Well, 1's smaller, so that's all I can take out. If I take that all out, what am I left with? Well, I'm left with this 3 and the x. So 3x. Okay, I took out both of these, so they're gone. And I took out one of these. So I'm still left with a 4x minus 3. Plus, I took out the 2, so that part's gone. I took out one of these, that part's gone. I didn't do anything with the 4, so I've got a 4 still. And I took out 2 of these, so I'm left with one of them. Okay. So I'm still simplifying. When I do this, I'm not changing my common factor. Stuff that's out front is just going to stay out front. I'm not going to expand it. I'm not going to change it. I want to leave it in brackets. But inside the big square bracket, I'm going to try and simplify. And I can do that by distributing. So 12x squared minus 9x and 4x squared plus 20, and then collecting. If I collect my like terms, I got 16x squared minus 9x plus 20. And there's our simplest form of that derivative. Okay. And get you guys to try one. Same idea. Can you take the derivative and simplify this as much as possible? Give it a try. Pause the video. See if you get it right. I'll put the answer up here, obviously. And we can compare. So f prime. Product rule. 2 parts being multiplied. So the derivative of the first piece is 15x squared times the second piece. I'm going to put this into bracket form with an exponent. Okay, so the derivative of this was that, and I just kept the second piece the same. Plus, derivative of the second piece. Okay, times the derivative of the base. Oops, just an x. Times the first piece. Okay, let's see what we have in common. Common. Ooh, I see these that both have things that have a 5 in them. 5 and 15 have a common factor. That would be a 5. X squared and x cubed have a common factor. It would be an x squared. And I see that this base is in both. So a tricky idea here is I got to think of which of these is smaller, positive 1/2 or negative 1/2. And that would be the smaller base, right? So my common factor is the negative 1/2. Okay, if I take that out, what am I left with? Well, 15 divided by 5 makes 3. So I have 3 left. The x squared I took out. I had a positive 1/2, and I took out a negative 1/2. When I take things out, what I'm really doing is I'm subtracting my exponents. So a 1/2 minus a negative 1/2 leaves me with the number 1. So in other words, I have 2x squared minus 4x plus 1 to the 1 still. That's what's really left. Okay, and the next piece, I didn't touch the 1/2, so I still got the 1/2. I took this whole thing out, so that part's gone. I didn't touch the 4x minus 4. I took out the 5, I took out an x squared. Oh, I still got one of these x's left at the end. Okay, we got to simplify this. 5x squared, 2x squared minus 4x plus 1 to the negative 1/2. In my big bracket now, let's simplify that. What do we get? We'll get 6x squared minus 12x plus 3 if I distribute. And over here, a 1/2 times 4 is 2x. I'm going to do this both at the same time, okay? So 1x on the top. So think of it as 1 times x times 4x. Right, that's what it is. What's happening on top divided by 2. So in other words, we'll get 2x squared. And if we do the next piece, so 1 times x times 4 would be negative 4x over 2, or in other words, negative 2x. And if I simplify, I'm going to leave my bracket, my exponent, as a negative 1/2. I could move it to the bottom if I wanted to and write it as a root sign, but I don't need you to do that if you don't want to. And the brackets we can collect, we'll have 8x squared minus 14x's plus 3. And we're done. That's the derivative. Okay, so don't change the common factor and leave it the same. You could write this piece if you want to as a on the bottom part with a root sign, but you don't need to. And make sure you simplify the bracket at the end. Okay, let's look at the next example. In the next example, I want us to think of it in two ways. We're going to try this question twice. Same question. We're going to approach it as a quotient rule question and again as a product rule question. And you're going to have to decide for yourself which of these two methods you prefer. Down the road, it'll be your choice. Do you like to do it this way or do you like to do it that way? But for now, we'll go through both so we get the hang of it. And so method one, let's do our quotient rule. Our quotient rule states that if we take the derivative of the top, which is 3x squared, and times it by the bottom, and then we subtract the derivative of the bottom and multiply by the top, we then have to divide it by the whole bottom squared. That will be our derivative. But that is definitely messy, so we need to simplify this. So we can use some of the ideas we just did previously. We're going to look for common factors on the top. So what do I notice? I notice they both have a 3 in them. And I notice that they both have the bracket the same. I'm going to take the smaller of my two exponents, which is a 2. I'll be left with on x squared and one of the brackets for the first half. On the second half, I'm left with the minus sign, and I'm left with the two other brackets, the 2x plus 3 and the x cubed plus 2. On the bottom, if I apply my exponent rules, I'll get a power of 6. Now, one of the nice things about the quotient rule is that we often have things that can cancel top and bottom, and sure enough, we have that here. I can cancel these two with 2 of these. So I'm really left with 3, and then the big square bracket. And we know what the big square bracket, we want to simplify it. So let's do that. X to the 4 plus 3x to the 3 minus x squared minus, I have to do FOIL, 2x4 plus 4x plus 3x squared plus 6 all over on the bottom, after we cancel some out, that. Okay, we're not quite done yet because we have a bracket we can simplify. Let's do it. Okay, so we're going to collect some like terms inside this bracket. I can put the this x4 with minus 2 of these. I'll give me negative x4. 3x cubed minus 3x cubed gives me no x cubes. That was a cube, right? Yeah, I missed something there. 2x. This should be a cube, guys. Sorry about that. Negative x squared is the only squareds. I have some x's. I have minus the 4x's, and I have minus the 6. Minus 4x and minus 6. Can't really make it any simpler. We're not going to change the bottom, so we're done. There's our derivative, as simple as it gets. I suppose if you wanted to, you can multiply everything by 3 on top. It doesn't really make it simpler, it just gets rid of one of the brackets, that's all. Okay, so that's by the quotient rule. We're going to do the exact same question, but we're going to try it by the product rule. Some of you might like this better, some of you may not. It's going to be your choice down the road which way you want to do it. To do this as a product rule question, we have to change the format of the question. We've got to change from dividing into multiplying. So that means I need 2 brackets side by side. I can do that by applying an exponent rule. My exponent, oops, 3. My exponent becomes a negative, and I bring it up top. Now it's a product rule question. Let's take our derivative. Okay, derivative of the first, 3x squared times the second piece plus derivative of the second piece, subtract your exponent, derivative of the base times the first piece. Okay, so lots of parts and pieces. Hopefully you have some common things. We definitely have a 3 in common. We definitely have a bracket in common. What's smaller, -3 or -4? -4 is. What are we left with? An x squared. And if I have a -3 and I subtract -4, I'm left with a +1. So in other words, I have one of those, right? I don't just show the one, but there is one of those. And I've got this plus minus thing going on here, so I'm going to fix that. I'm just going to call that a minus. I took the 3 out, I took the bracket out, so I'm left with these two brackets at the end. 3. Okay, we're simplifying. What do we got? We got x squared plus 3x minus 1 to the -4. Inside the brackets, I can expand, so x4, 3x cubed minus x squared minus, I got a FOIL, 2x4 plus 4x plus 3x3 plus 6. I can collect inside the brackets. And what do we get? 4x to the 4 minus 2x to the 4s gives me a -x4. These two things are going to cancel out again. I've got minus x squared. I've got a -4x and a -6. And there's my answer. And if you stop and look for a second at our previous answer, we had this one. Oops, put this all together here. This answer, and compare it to the answer we just got, these are the same answers. The only difference is that I wrote this one with a negative exponent, but really that's the same thing as putting it down here, right? So it's your choice. They come to the same answer either way. The quotient rule, the problem with the quotient rule sometimes is that you have to write fraction after fraction after fraction, so it takes up a lot of space. The product rule, same math, less space because it's all written on one line. So it's really your choice. I suggest using quotient rule if we have things on the top and the bottom that don't have multiple exponents. So for instance, if I had a question that had, I don't know, 1 over x cubed plus 2 squared. Well, I only got an exponent on the bottom. That would be a good quotient rule question. But if I have exponents on the bottom and the top, then I think the product rule is actually a faster way of approaching this. But it really is your choice. You get the same answer either way. Okay, I'll give you one more to try. See what you guys can do this one. I'll do it both ways. You pick one way. You see if you get the right answer, either the product rule or the quotient rule. So pause it, try it, see what you can do. I'm going to start with the quotient rule. Okay, exponent of the top times the entire bottom. Oops, minus. Exponent of the bottom times the entire top, all divided by the bottom squared. Here's our quotient rule. Now we've got to simplify. Okay, so one of the tricks in this one, you might notice, 2 times 6 makes 12, and 4 times 3 also makes 12. So they have a common factor of 12. They also both have a 6x minus 1. They also both have a 3x plus 5, and the power of 3 is the smaller. And we're left with, well, just 3x plus 5 from the first half, minus, in the second half, I'm left with just a 6x minus 1. All over on the bottom now, 3x plus 5 to the 8. I think we should be able to cancel some top and bottom stuff, which we can. And I can cancel all 3, which makes this a 5. Inside the brackets, that's an easy thing to collect. Of negative 3x and 5 minus negative 1 is plus 6. And on the bottom, we get a 3x plus 5 to the 5. And we're done. There's our quotient rule. Hopefully you got that answer. Either method. I'll show you both just so we have the right answers. Show that it works. You can use which method you want to. Okay, 6x minus 1 squared turned to a product. A negative exponent. So our derivative, 2 times 6x minus 1 to the 1 times 6 times the second half plus second half times the base times the first half. Here's my derivative. Let's work on simplifying it. Again, we have that, and you have to kind of notice this. It comes out to 12, and again that it comes out to 12. Those two things being multiplied together. If you didn't recognize it's not the end of the world, you could common factor again later on. And if you notice, oh, there was more common factors, then if you can look for common factors off the bat, why wouldn't you? We got that, and we have to the negative 5 is smaller than negative 4. Okay, what are we left with? Well, from the first part, just 3x plus 5. From the second part, we got the minus sign and the 6x minus 1. And so our last line, we got the 12. We got our common brackets and our simplified brackets and the same answer. Okay. Now, you actually could take this a step further. You might notice that, hey, those are both divisible by 3. They have a common factor. Well, if they have a common factor, that 3 should really come out. So, an even better answer for this one would look like that. Or if you will, 3 times 12 makes 36. And you end up with that answer. Okay, so that would be the best answer. Okay. And in case you hadn't noticed that that 3 and the 4 made a 12 and the 2 and the 6 made a 12, this idea right off the bat, you didn't find a common denominator at all, well, again, you could take a common denominator out at the end. You might have had a common denominator of 36 in this bracket. Right? You had, what, negative 36, x plus 72 or something like that, maybe? Okay, well, if you have that, these can be also divided by 36. And it'll come out to the same answer as this. And your 36 would be out front. Maybe you may not notice it at the end. And if that's don't notice it, that's okay. Just make sure you at the end you common factor it. Okay, that's it. That's the lesson. Try some of the examples. Make sure you can do some derivatives. As I said at the beginning of the lesson, we're going to start looking at some applications. These applications depend on us being able to do the derivatives, because that's our first step. When in doubt, we're going to find the derivative.